All right, here we are. I am doing a hardware stream, which is sort of terrifying for me. I've done a lot of software development. I've done almost no hardware development. So I'm sort of testing my setup now, but the end goal is basically to have a computer. I'm gonna start pulling stuff out to show you. So this is a modern version of the 6502 chip. Let's see if I can get us to see some. I think I might have to zoom in, I guess, to see that. Oh, yeah, it's upside down though. All right. A modern version of the 6502 called the 65C02. It is still manufactured and still used in hardware applications today. This is basically just a toy. This is a version of the same chip that is used on the. Sorry, it's a little hard to navigate here. It is used in the Atari 2600. I'm gonna try and limit that shaking. I need to come up with ideas for that. So I think one thing I can do is just lift this ever so slightly. Okay, cool. Shaking is a problem. So yeah. And the idea here is that I'm gonna just do some fun little stream stuff with this. Basically trying to I'm gonna feed Wi-Fi signal, maybe not even from an Arduino. There's another sort of little device that I think I can that you can program directly. That's pretty popular for Wi-Fi signal, and it's much smaller than this. This is an Arduino Mega, um, or a knockoff version of the Arduino Mega. But eventually sending serial data over to this chip to do something. I think I can drive an LED with it, so I'm going to try that. And I'm trying to think of anything else that's super important to tell you about. Oh yeah, and I'm going to try driving like an audio buzzer with it as well. Basically, getting stream notifications on hardware. If all goes well, and I like how this works and I like the circuit, I might get a printed circuit board and eventually solder all this stuff in. Um, so, looking setting up these breadboards. Um, just to note, all of this stuff is based on, and it's actually comes in a kit made by a guy named Ben Eater. I will link his YouTube in here. Let me actually just make a. So we'll just like stream notes. And we'll call this hardware one. Notes. So Ben Eater, he's got a YouTube channel, but he's got all of his stuff, and including kits to build this stuff yourself at eater.net. 6502. So the goal, so what I want to do um, oh, and here's a nice pinout of the Arduino Mega. So what I want to do for this stream is see if I can get this chip powered, running, and if I can get it. I want to use the Arduino to read sort of the data and address bus that are or that's coming out from the chip. So that would be a goal. That would be a success to me. Is getting some output from the chip to print through the serial console of this Arduino Mega. Which I have done a couple tests, and I think that I can easily write Rust to do this, which is fun. Although it means I can't really use the Arduino IDE, but I think that is fine. One last piece of information. I can actually just show you this at work. I believe this is. Need to find a good place to hook this up. Um, this is a little clock module, so I can actually like step through instructions. This one's ground. That's the wrong way around. That's ground. Does that make that looks right? This one's positive 5 volts. And if I plug this in, I can show you what that looks like. And I'll try and figure out how to get my arm out of the way, but you should be able to see, yep, on the camera, that lighting up. So I can single step through instructions this way. This will be the clock. There's actually in the kit, there's a 1 megahertz clock, which is what I'll be running it at eventually, but this can act as a clock in the meantime. Basically, let's switch to the other mode and you can see it flashing here. Let me use this. This is a little easier. You can see it flashing here. There's a potentiometer over here, so I can carefully change the speed at which it flashes, slowing it down. Basically, this is using 3 5 5 5 timers, one in astable mode, so that's the flashing mode, one in monostable mode, so that's allowing me to press this button, and that basically just debounces this flash signal, so you don't get contact bounce. And then another in bistable mode, which is what the switch is running on, which debounces the switch too. So you can see as I move this back and forth, I can go between clock pulses. Um, and change the speed. So that's about it that you need to know for that. I went through and sort of made either had or made jumpers for all this stuff to make it nice and neat and easy to see. I think for the time being, what I'm going to do is use. Let's see if I can use these jumpers. These. Uh, um, to hook everything up at first, so it might be a little messy, but it should be a lot easier and a lot more fun than watching me like strip wires and stuff the whole time. All right, so let's get started. What I'm going to pull up, so I got the pinout for this. I think Ben Eater actually has a pinout for the eater.net. At least he's got a link to the data sheet. So this is the kit that I was talking about. Uh, Here's the data sheet. And then I will scroll down to the pinout. And then we can go through sort of all of these and hook them up. So I think I'm going to put the chip at 5 here. And, oh, you guys can't see, so I'll switch over while I'm hooking all this stuff up. So counting is a definite issue because there's 40 pins on this. So I think I don't want to put it all the way over here at the 1, although that would be really convenient. It just makes it hard to tie some of the to the power rail a little bit. So I'm gonna start at like, and I don't want to start at 10 because I'm wasting a bunch of time there. Actually, I'm gonna do a manual reset for now. There's a reset that needs to happen. But and that would require a button. But I think I'm gonna do that manually with a jumper wire for now. So let's see. Put that in. Make sure that's nice and centered. And that's at should just all pop into place. Okay. I need to connect these guys to power. I'm trying to figure out how best to do that. So I'm just going to connect those together, and then I'm just going to tie jumpers across from this power rail and across the. Got a big old bag of jumpers. Making sure my mic is still good. Testing, yeah, that's good. Should have opened this ahead of time, I guess. I'm going to try and use appropriate colors where I can. These are... I need a knife is what I need. Oh, you know what? I have some tools in here. Let me grab them, or they went somewhere else, but I can find them really quick. That will help me with that. It's gonna be a mess of cords, but that's fine. All right, so we'll do reds for positive 5 volts and just connect. Pretty simple. Connect these, and then connect. Doesn't really matter where. And then we'll use these black ones for ground. Actually, I'm probably going to connect my Arduino. We'll figure it out. So tying negative or to ground, that's not 5 volts. That would have been a problem. And then ground to ground over here. And then we can check that power's still working by, or then that's hooked up correctly by hooking in the Arduino over here. We can see that our clock is still flashing. So then we're going to go through the pins one by one. I'll grab my pointer here. Let's make sure I put this in the right way. Yeah, the notches to the left. Trying to remember what all of these are. Actually, it might be better if I... Okay, what I do know is that the reset pin is pin 40 over here at number 5. So I actually may need to move this down because I want to be able to put a little more. So I'm going to tie that to ground, I think, with 1,000 ohm resistor. Let me pull those out. Wait, let me see. That's the reset, and is it active low or active or RESB pin 40? Looking through the held low for at least 2 o'clock. Yeah, so that is an active low signal. Okay. Okay, found my 1,000 ohm resistor here. All right, so basically I'm using this resistor to tie it high, but I want to be able to manually reset this chip. So I'm tying that to 5 volts. Let's see, I might be able to actually zoom this in just a little bit. I'll turn this off for now so it's not just flashing in everybody's face. Okay, and then I'll have, so if it's tied high, then I need a low signal. So we'll get an appropriate color wire for that. So, so basically to reset this, we'll take this reset pin that's set at a high volt or that's held at a high voltage, and we'll take it low, and then uh, pull it out back to high for normal operation. Get this a little more square in the frame. Okay, cool. So then I need to go through the rest of the wires. And I'm going to use a little bit here. I'll switch over to my other scene. I'm going to use a little bit of a cheat because I don't remember exactly what all of these are. I know some of them just need to get tied high or low or whatever. Um, but um, but I'm going to use Ben Eater's like little schematic here, just so you see what I'm looking at. Um, and he does some stuff that I'm not going to worry about. Like he has the ready tied high uh, through a 1K. Do I need to do that? I don't think so. Maybe there's some reason I need to do that through a resistor. I don't think it matters. IRQ is active low, so that's gonna be tied low. So we're just gonna go through pin by pin, and I'll just switch back over. I actually need to switch scenes so I can look at the. There we go. All right. So pin one is something I don't quite understand. It's like a reset or some IRQ, some vector that I don't know that is often used or maybe is never used. Pin two is I'm sure it's used in some situation. Is the ready signal? I think we can just go ahead and tie that high. So that just stays on. He had it in that schematic through a resistor. So But I don't think there should be any problem with just tying it high. The next one is an active low interrupt request. So I do believe we can just tie it high. No need for a resistor there. We will eventually deal with this interrupt request when we're doing getting signals from the Wi-Fi card, but not right now. Okay. Um, then the next one we don't care about. The next one needs to be tied high. That's NMI. That's a non-maskable interrupt active low signal, so that's on 6. Let's see. So this is 1, 2, 3. So I need to skip one here. So 1, 2, 3. This is pin 4. That's the interrupt request, and pin 5 is the non. 2, 3, 4, 5, 6. So 1, 2, 3, 4. Okay, I think I got it. So sorry, I'm looking. So I think I've got it right. Pin 5 is we don't care about. Pin 6 is the non-maskable interrupt. So we're just gonna go one more, and we don't want to trigger the non-maskable interrupt. So we'll tie that high as well. This is gonna be a complete mess over here. But hopefully you guys can you'll be able to see it. I'll try and move stuff out of the way. Cool. Pin 7 is an output. It's a sync output. We don't really care about it. And then 8 is VCC. So this is pin 7, pin 8. And then we have a bunch of address lines. And pin 8 is power for the chip. So that's going to go to. Let me disconnect power while this is happening. I think I'm fine, but okay. And then we should have 11. We should have 12 address lines on this. Let's see if I can get us zoomed in just a little bit. Okay. So this is 1, 2, 3, 4, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I may have counted wrong. Let me check all my connections again. So this is pin 1. Pin 2 has something in it. Pin 3 is like between here. Pin 4 has something in it. Pin 5 is between here. Pin 6 has something in it. Pin 7 is between here. That's pin 8. So that's pin 9 through 20. So that should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I just must have counted wrong. So those are 12 of the address lines, and then there is ground over here, so we'll tie that to ground. Sorry for the shaking. I just need to get things sorted out. Okay. So then there should be one, two, three, four more address lines over here. So that would be one, two, three, four, and then eight data lines. So one, two, three, four, five, six, seven, eight. And then we should have a read write, which is right here. And that's an output, so that is whether the chip is reading or writing from the data bus. Um, and then NC is just a not connected pin. And then BE looks like it's tied high. I'm not sure. That's bus enable, so that like we're gonna tie that high because we want the bus to always be enabled for now. Let's go the other way. So we have a reset here. We have some timer output stuff there. We have something that's another output that we don't care about. We have the clock, and then we have bus enable. And bus enable we're tying high. So let's actually make sure that that all makes sense. The pin 40 is our reset, and we'll reset by just connecting like that. Okay. And then so it's actually easier for me to do it this way. So pin 40 is that. Pin this is the clock output we don't care about. This is it's another output. I'm not sure exactly what it is. So this is clock. Did I do this wrong? Okay, reset pin 40. Clock output pin 39. Another output we don't care about, which is 38. Clock input, which is 37. And then yeah, so I think we counted wrong. So we need to be one more over. Okay, let's try that again. We have a reset here. Oh, let's get this out of the way. I need to get used to like watching the screen instead of looking at the board itself while I do this. So this is our reset on pin 40. That's one over. That is clock out, which we don't care about. This is another output that we don't care about. This is clock in, that's right. And this is our bus enable. This is a no connect. Then read write. Then we should have 8 data bus lines. So 1, 2, 3, 4, 5, 6, 7, 8, followed by 1, 2, 3, 4 address lines. So 1, 2, 3, 4, and then ground. Okay, I think we've got all that set up. So we have officially connected our chip. Now what we're going to do is hook up our Arduino to the address lines and to the data lines. What would be more interesting right now? Oh, we'll figure it out. 2, 3, 4, 5, 6, 7, 8. First, I'm going to switch back over to code, and show what the Arduino looks like. Made a complete mess over here. It's fine. So here's our Arduino, and basically just going to prove that that this works by building a quick little library, and so it's cargo generate. This is the template, and it'll say unknown. I don't have a config file for cargo generate. That's fine, and we're going to call this. Let's call this. Rest 6502. Doesn't really matter. We have an Arduino Mega, and then it should have made Rest 6502. And this should all be set up. Oh, you guys are not seeing this, so let me switch over. So this should. So this is all the stuff I did. I basically, yeah, I use this template. It sets up for the chip, and then fortunately everything kind of works if I remember correctly. If I just cargo run, it should compile everything, and I'll switch over to the Arduino when it starts doing something interesting. But basically, a bunch of people have done an awesome amount of work to make all of this actually work properly. So writing Rust for embedded even Arduino boards is actually pretty easy, and it'll give us serial output. So we'll be able to, yeah, you can see here's the serial output, and yeah, and actually if I switch over to here, you should be able to see it blinking. And if I reset that, you can see that the reset interrupted the blinking and it started again. So that's proof to me that that's working. So I think the thing that I need to do is hook this up to all the address lines. I don't. Do I need to show that? Yeah, I'll show that. So I've got this. Oh, sort of string. I think it might be too many. 1, 2, 3, 4. But regardless, I'm just gonna start hooking this up on the even side of the Arduino over here. Let me pull this. Let's start at 22. So it'll be 22 through like 24 or something like that. I may need to loosen these up just a little bit so I can negotiate them. Yeah, because they're like kind of twisted. Let's see if I can do that. I just need to get practiced at watching myself on screen doing it so I can see what you guys are seeing. Whoop, and there I just took off the little guard. I think it should be fine. So don't pull by don't pull by this little plastic piece here. Whoop. It's a big separation. So we have 16 of these we need to hook up to our bus. I think that's 16. I think I added a couple extra. I'll just pull them off in a second once I verify that. So 22 through And then again, try and use what it tells me is that people who do this a lot, it's no joke. They have 1, 2, 3, 4. It's the one that came off a little bit. This is not as easy as I expected it to be. That's 6 in, 7, 8, 9, 10. Oh my. And make sure I have these the right way around too. It's like pulling some of them, like makes the rest of them want to come out. So that's really fun. Note to self, I can set this stuff up pre-stream if I want to, and that might make life a little bit easier. So let's take a look at this and make sure this makes sense. So I think this is 20 through. So I'll do this. So, oh, get out of my way. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so that is, I do have 16 there, so I'm going to pull off these other two. We are going to hook up more to this, but, and I'm going to start at the lower side, I think. Let me check, make sure that I have the addresses correct. Yeah, address 0 starts right after our connection to ground. So, um, come back over here. I'm gonna pull some of these apart a little bit again. I'm worried I got something like mixed up in order here, but we will find out. That should be pretty visible. Then four of them are I'm going to need to pull pretty far apart. So one, two, three, four. Because they're going to go to the other side of the chip. I'll just have to make sure that they go in ascending order the kind of other way. So I'll probably have to flip over. And then I'm going to move that out of the way. And then see if I have a little more luck getting these all in this other side. Than I did in the Arduino. I skipped one. Let's see if I can move that a little bit. Okay. This is proving harder than I expected. Putting jumpers in the breadboard. I'm going to separate these just a little more so I don't pull them out as I'm putting them in, basically. In the meantime, enjoy your listen to Blackbird by the Beatles if you're not on YouTube or in the VODs. There must be a trick to this. I need somebody who's put a bunch of jumpers in a breadboard to walk me through how this is supposed to work. So I'm gonna potentially, once I get these all in, I'm gonna see if I can get something running. Although I would like take the clock in too. That's out of order, isn't it? Yeah. So then next after red is orange, then yellow, and then green, and then blue. Okay, I think I've got the first few addresses of the bus set up properly. Whoa. Sure that I was knocking this around a lot. Yeah, I need to figure out a better way to mount this camera. Sorry for so then it's just sort of the other way around. It's going to be purple, gray, white, and then black going the other way around. So I'll go ahead and try and pre-twist it. Bend that a little bit. I think the biggest problem is they're kind of stiff, which makes sense. I need to pull these a little further apart. I think that's the lesson I've learned is that I need to separate these just a little bit more so I'm not pulling them all at the same time. So then with the twist, get that reset out of there. Here, I'll pull the ground out. Well, it should be okay. Here, I think I just need a little more separation there too. Bend that. Yeah, I'm struggling here, but that's okay. That's what this is all about. Do I have a cable port for the breadboard? Hey, Perkin J, how's it going? Um, I'm actually just I'm not. You may be talking over my head, so if I'm talking about something different than you are, please let me know. Because I don't really know this stuff super well. I'm basically setting up. Um, if I'm getting what you're saying, I'm going to be powering the breadboard with the Arduino 5 volt and ground for now. Is that what a cable port is? If not, tell me what one is. Okay, I think I finally got everything in. It looks like it's all in order. Do I have anything twisted over here? Don't think so. I think that I have everything going. Um, so ground is still in. We'll need to pull the clock signal over, which I forgot to do earlier. So that's interesting. So the clock is uh on pin 4 or what is it? 37. So this is 40, 39, 38, and then 37. So it's right next to this. So the clock is over here. We'll make clock be blue. That's our clock signal. It's coming from over here. Wire's a little bit short, so that's hopefully is enough of a connection to make that work. And then here's the clock. Oh, let's move this up. And this is the clock wire from, and I'll zoom out again. Then I messed up my camera. Should be back. Might need to do some magic with. Wasn't expecting my camera to break. Maybe I need to get rid of this projector source here. Deactivate, activate. Well, this may be a short stream. Oh, there it goes. Okay. So then the Arduino is going to hook into the same clock signal right here. And then before we hook up power, I'm going to see if I can get this software written. It shouldn't take too long. It's also where I feel more comfortable. Yeah, it looks like, oh yeah, I unplugged the Arduino, so it. Okay, so let's open this up. I think the only problem is that I couldn't get cargo to, or I couldn't get a rest analyzer to work properly, so I'm gonna kind of have to like, I might even have to turn off. Let's see, it's gonna complain, so I may turn LSP off. Let me switch to my view that you can see that on. Okay. So I did a little test, so I know that interrupts work. So I should be able to get this written pretty quick, and we can just test that interrupts work. So it's this. I should be able to copy all of this over. LSP. So just turning off LSP for now. Okay, here we go. So most of this stuff will be much the same. Yeah, we'll just copy this for now, just exactly as is. And then need the feature. And this is on interrupt to the 0 hardware, so that's fine. That's that top pin on the Arduino. Okie doke. So we'll do something similar to this for now. I'll explain what all this is in a second, but you won't have to watch me figure all this stuff out. So basically, what's happening here is that I'm setting up the serial, which is what the runner sort of listens to, and then I am just writing something to the serial to show that it works, and then I'm switching around. So this is rising edge. This is changing the setting I was on. This is all a little bit. It's all a little bit Greek to me, but I'm figuring it out. This sets bits to be on the rising edge. And if you want it on the falling edge, I believe it's 03. but we'll leave it on the rising edge for now. And then this enables it 0. Now this library, like in some cases with some chips, it has like a special way to access all the individual sort of interrupt bits. This one doesn't have that set up. It'll need a new PR. But basically, this is getting all the whole interrupts register, which is 8 bits. I think there's 8 interrupts on the Arduino Mega. And sorry, trying to figure out the lighting situation here. And so this is actually just setting the first bit, which happens to be interrupt 0. Have to enable interrupts. It's unsafe. Don't ask me exactly why it's unsafe. I'm totally not sure. And then basically, what I'm doing here is in the loop, I'm sleeping, and if I am woken up from that sleep by an interrupt, I just say it happened for now. And eventually we're going to be printing out whatever's on that pin. So I should be able to run this now, unless I've missed something. Cargo, and see some of that output on the serial pin. I don't have the clock hooked up yet, but I will do that in a second and show you what it looks like. I need the prelude. So something I missed here. Okay. I think it's an import. Yeah, it's this Arduino HAL prelude that I missed. And then I forgot I need to do that. We can look at the cargo toml here. Let's see. AVR HAL, let's see. Interrupt test. Cargo toml. We just need to declare AVR device in our cargo toml. Otherwise, it can't find it. It's already there, but we don't have access to it. So that should be all I need. Right, I don't have the Arduino plugged in. That's why it's... So I'm going to plug it in. And you can see I have serial set up, but I don't have the power connected, so I'm not actually getting interrupts on that pin. So that is, I will switch over to... Oh. Boy, my camera is really... I'm using something to... Give me a second. I think it goes to sleep. I'm using like my cell phone camera because it's by far the best camera I have, especially for zooming. So I'm using just a little function of it that... Okay, so I think what I need to do is open a windowed projector so that it stays running. I'll move that. That's not what I wanted. Move that window around. Okay. And that should allow me from here. Okay. Yeah, and that should keep it open. If I can't work that out, I may have to go get a different camera. But if I did everything right, I should be able to cancel that connection. These are, let's see if I can go over here. Here's my power, so that is the yellow is positive in this case, although I could switch those out. And the gray is ground. And that should get the, if I switch over, okay, so that should start flashing that. And now if I attach to serial, I should be seeing that interrupt happening if I am correct. So you can see that interrupt is happening. And it's happening with the blinking of that LED, although it seems a little funky too. I think it's just how it's showing up, but I think that's happening pretty regularly. And I'm gonna just up the speed of it, and I should be getting more. Yeah, now they're happening all the time. That's like way max speed. But here, and I'll show you what that looks like over here. All right, it's going kind of nuts, and we're getting a bunch of interrupts. And then if I stop it, you can see that it's not writing anymore. And every time I click this button, I'm getting a new write. I don't know if that's showing up on the stream, but it's pretty quick. Um, so that sort of proves that the Arduino is hooked up to the clock. So it does look like that clock signal is coming across. Let me show you here. It's coming across. This is a pretty tight jumper coming across to here and then being picked up by this Arduino uh, clock pulse and going into the interrupt here. So the thing that we need to do is when we get that interrupt, we need to read these address pins. So that should be fun. And I may pop open some examples from that project because I need to like downgrade some pins and stuff like that. Each pin has its own type and rest. So, um, AVR Hell. We're looking at examples. Most of the examples are on the Uno, so let's see what they have here. So we're looking for input. Maybe we could see some of that in SPI stuff. Oh, please stop. Stop. Pull up and into pull up input. So that's all we're getting. Let's see. So let's see what we have on the pin. So we can also downgrade, which I think is kind of what we're going to want. Um, to floating. With no external circuit pulling the read. I don't think we want. So maybe we don't need to pull it up because I think that uses the internal resistors. So I think we can probably just see digital output. Let's see. Let's look at digital input. Check whether the pin is driven high or is low. So let's see. Is there? I guess it's probably just in digital input. I think this works. Okay, so what it's going to look like, and so in order to get them um, into an array to loop over, I'm going to have to downgrade all of these um, pins. So it'll be like 22 through something. Sorry, let me see. Yeah, so it's like that. So that was showing us it's making an array. So we know it. Yeah, we know what it's going to be. I think it'll infer the types and stuff, but we can. There's a mode output here. So maybe we change that into input. Let's find out. So we're going to have 16 of them. So it's going to be pins. Let's see an example. Sorry, I'm just looking through this. Pins, and we're going to do PD22. And then we're going to downgrade that. Let's see if that much compiles. So I guess I don't need the PD22. I guess I just need the digital one. So that actually works fine. We're sorry, just testing it. Okay. So then I should be able to do so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 16. I don't think there's a better way to do this because these are all different types. So I think I have to actually loop through all of them. Um, let's see. 36. Let's get rid of that. Then we could probably actually just make this a little so see if that works. Yeah. Cool. So that's how many is this? 2, 4, 6, 8, 10, 12, 13. We can actually take a look at our thing and see how far it goes up. So 1, 2, 3, 4, 5, 6. Actually, we'll just split them into bytes because that'll make it easier to read. 1, 2. So let's call this byte 1. 1, 2, 3, 4, 5, 6, 7, 8. Byte 2. Probably just do some math, but you know, 1, 2, 3, 4, 5, 6, 7. And if we switch over here and we zoom in, we should hopefully get a match. $48. Looks like we're in pin 50 there. So let's make sure that matches what we're looking at over here. We got to pin 52. Maybe this doesn't line up as well as I thought. So we start. Okay, we actually have a pinout for the mega, so that's not it. Ah. So we can take a look at that. Need to open this in a new. Here we go. Uh-oh. So we can see it actually starts at pin 20, and it looks like I may have all this stuff kind of set up improperly because let's see. I may need to move all this stuff over again, which is not my favorite idea. Yeah, so I need to move all of this over by one. $22. All right, bear with me. Let's turn the power off. Hopefully I can just kind of like do the whole thing at once. That's probably wishful thinking. Yeah, that was very wishful thinking. It's going better than last time, although it's still not super straightforward here. It's like I can get two at a time pretty solidly. Let's see if I can get three. Or even four. I do love the ultra close up on my nails here. Okay, I believe that is more correct, although I have one that's in the wrong. Let's see if I can get just that one out. Okay, I think I didn't Hopefully I didn't pull anything out over here. I think I'm good. Okay. So if I cargo run, I still should have this interrupts coming in. Yeah, okay, so that's going on. All right, so I have the address pins, and basically, I'm looking for ones and zeros in this address pin, and I will be putting them, like basically stuffing them into a byte. So we'll just do like, we'll just do let mute address equals, um, we'll call this, it's a 0, C16. This will be 0 to start with. Pulling all these down, and then basically every time I get an interrupt, instead of just writing a line that interrupt happens, I'll also do a quick loop here. So I do need to know how exactly to pull data from the pin. See digital input. So I can just check that pin if it's low or if it's high. Okay. So 4, and we'll just index into that array with a number between 0 and 15. So 4i in 0 to 15. And so we'll make ourselves a so we'll say our address is equal to 0 here. I actually don't need that all the way up here. And basically for each one of these, we're going to be getting 0 through 15. So we'll be, so we'll do address, and this can be a, or equals, we're going to do, what is this? And then we saw that we can do is high. And we'll OR that with as U16. It's the Boolean as U16, and then we're going to shift that over by our I. We're going to shift it left by I. And then I think that'll do it. So then we can just write a line. We'll do that. 0x. Do that 6. I'll do that in hex for now. Might want to look at it in binary. call this address. We'll see if that compiles. Okay. Not interpreted as shift, interpreted as generic arguments. Right. I need to put different parentheses around that. Okay. This might be a limited. Okay, well, we can see what it looks like. So I'm a little bummed here about the input floating dynamic. Method not found. Oh, I need to index into that pin. Okay, yeah. And it didn't like this. So maybe it doesn't support this yet. Because this is not the standard libraries. And then we probably need. Still doesn't like that. Yeah, okay. Let's just see what happens if we do this. Well, we're definitely getting something. It does appear to be jumping around. Let me see if I can figure out how to format that differently. This is like a special library, so it's like so I would like to see what that is in either binary or hex. But it does look like we got to the point at least where we can read the address lines, assuming that everything's set up correctly. And then the next step is actually going to be to tie the it's going to be tie some the data lines high and low based on what we're doing. So hold on 1 second while I this U rate line that I'm may actually have better luck just writing out each. Yeah, so it's particularly fast, but it's a very limited subset of the formatting. Um, that's really annoying. Okay. So let's see what we can do here. So instead of writing out the whole address, we don't even need to save it into this address variable. We can just We'll just use the right one, and we'll just output the bit. It should go up, and then after the loop, we'll give ourselves a new line. And this is address bit. Ooh. Yeah. Arguments never used. Yeah, we don't need it here. Let's stop that. So you see that it's sort of jumping around places. Um, I think that's because we have zero input to this thing. And I think the next thing to do, although I think I'm going to stop the stream now and we'll do this next time, is going to be to tie all these. Let's see, let's move over to our scene here. It's going to be to tie all of these data bits here. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, it's running into all those data bits in because this is where it'll be grabbing instructions from. So we can actually put we can put no op in there, and then it'll sort of just run no ops forever, and we'll be able to see um, we'll be able to see those jumping or incrementing rather than sort of jumping around randomly. So I do believe that will be a next time thing. And in the meantime, I think I'm going to let's go back to here. I'm going to clean up some of this stuff that gets tied in with some with with that's the problem. My phone's ringing right now. That's why it's blurring out. With some of these like nice jumpers, so that it'll be easier to see what's going on. But I think that is it. I'm gonna unplug power, and I will be back next time. I'm probably gonna alternate these and the Atari 2600 streams. So.